Welcome to another podcast. In this episode, we're going to be taking a look at percentiles of the normal distribution. This is going to be a slightly different command than the one we looked at when we were trying to find area, because in this case, we're already going to know the area corresponding to the percentage of data that we're interested in looking at. So I have two examples here. They both take data from the SAT data that we looked at in the previous video. Remember that this data is the June 2012 data for SAT test takers. We had about 1.6 million samples here. So I have two questions I want to look at with you. The first is, what is the minimum score that a person could receive on the mathematics test and be in the top 10%? So the mathematics test has a mean of 514 and a standard deviation of 117. So if we were looking at the curve, we'd be looking at something like this. And here's the idea behind this type of problem that's different from the previous ones. I'm looking for some score down here such that above the score is 10% of the data. So I want to be in the top. This is the cutoff score for the top 10%. In other words, you've got to make at least X if you want to be in the top 10%. Well, that means you did better than 90%. So what I'm actually hunting for here is called the 90th percentile. So I want to find the score on the exam that corresponds to the 90th percentile. In other words, the score that says you did better, not did you better, but you did better than 90% of the people that were tested. All right, the way to find this is a command in Math Studio called the inverse normal command. So let me just quickly introduce you to that command, inverse normal. And what the command uses is the percentile associated with the value you're looking for, the mean of the distribution, and the standard deviation. So this is the key point here, is that this percentage is the percentile as a decimal associated with the cutoff score X, this X right here, associated with that cutoff score. So let me go ahead and bring our calculator in. If you search in the catalog, inverse normal will be under the I's. And notice it only has a P right there, but it does have a mu and sigma option that you can associate with it as well. The P stands for the percentile. So I'm going to select that, and my percentile for this problem is the 90th percentile. So as a decimal, the 90th percentile is 0.9. And my mean is 514, and my standard deviation is 117. So this suggests that the score would be 663.94. So for this particular problem, as long as we scored above a 663.94, in reality, because it's SAT, 694 would be what you're shooting for here, that this is a score that's going to land you in the top 10% out of all people that took the mathematics test, based on the data that we have for this particular test. All right, similarly, I want to hunt for the quartiles for the critical reading distribution. So the best way, or the easiest way to do this, let's once again draw a picture here. And since we're hunting for quartiles, you need to know what is meant by a quartile of the distribution. We talked about this when we did box plots, but for the critical reading distribution, we have a mean of 496 and a standard deviation of 114. And I'm looking for the value of Q1 and Q3 which, if you recall what those points mean, they are the points that divide the data into 4 equal pieces, along with the median, which is Q2. And so there's 25% between each of these points. So if I want to find Q1, then that seems to me like it's the inverse normal of 0.25, mean 496, standard deviation 114, and Q3 would be the inverse normal of there's 75% below Q3. Remember, it's always the percentage below corresponding to the percentile. So Q3 is the 75th percentile, Q1 is the 25th percentile. All right, so let's bring in the calculator once again and see if we can figure out these values. All right, so inverse normal. Let's start with the Q1. And the inverse normal of Q3. All right, so I'm just going to round here to 419 and 573. Actually, let me go ahead and go out to the tens place. So 419.1 and 572.9. So the values that we have are 419.1 and 572.9. So in between these two scores is the middle 50% of the data. In other words, the average or the middle 50% of people that took this exam scored between 419 and 573, let's say. So this is the other type of question that you can be asked where you're going to have to use your calculator to find the answer, and that is finding percentiles corresponding to certain percentages. The percentile corresponding to the top 10%, well, that's the bottom 90%. And also looking at the quartiles, which we talked about when we did box plots. And so this is the exact opposite of the questions that were asked in the previous video, and a lot of times students will get them mixed up. So remember that when you're working with percentiles, you are given the percentage. As you can see here, I'm given the percentage. When I'm not given the percentage and I'm actually given the data points, then I'm being asked for the percentage between above or below the data points in that case. So just mirror images of each other, these last 2 videos that you've watched. All right, thank you for watching.